Hi guys, welcome back. So let us look at another example on the application of area of a triangle concept. So guys, this is going to be fun and exciting. In this case, we have a quadrilateral ABCD. And what we want to prove in this quadrilateral, and guys, you can also see that we have two diagonals and I have already drawn those diagonals. The lengths are already provided. This length is A and then this is C, then this big length is D and then B here. And the angle included between the two diagonals is we are going to denote, I'm denoting it by theta 1, you are free to denote it by anything. So guys, what we want to prove here is basically we want to prove that the area of this quadrilateral ABCD is 1/2 of the product of the lengths of the two diagonals, and I call them D1 and D2, but basically D1, let us say if this is my diagonal 1, then this is going to be D plus C, and the diagonal 2 is A plus B. So we want to figure out, we want to prove that the area of this quadrilateral ABCD is 1/2 of the product of the diagonals times the sine of the included angle, which is this theta 1. Okay, so how are we going to figure this out? Guys, there is probably more than one ways of doing it, but I figured it out using one of the ways. Guys, I'm going to share my way of doing it. If you have another way or you can come up with another way, feel free to share it with me or feel free to use it for your own, for solving this or for proving this area, right? So guys, what I did here was I said that if this is theta 1, then the opposite sides are going to be the same, right? The diagonals and the opposite sides, so it's opposite angles, I'm sorry. So this is also going to be theta 1. And then I said that, guys, we know that this, I call this angle as theta 2. If this is theta 2, the vertically opposite angles are going to be the same. This is theta 2. And also keep in mind that theta 1 plus theta 2 form a linear pair. And we are going to kind of keep that in mind as well. Theta 1 plus theta 2 is going to be 180 degrees. So I got to make a note of that. And then I just label them as theta 1, theta 2, and so on and so forth. Okay. So what I basically did was, in order to find the area of this quadrilateral, well, I could see that it is already broken into 4 triangles. This triangle 1, 2, 3, and 4. So what I did was I wrote the formulas for the area of each of the triangles, and if I sum all of the areas, I will basically get the area of the whole quadrilateral. So this is what I did. Guys, area of this quadrilateral, let us denote that by A of this whole thing, ABCD. So it is area of, let us call this 1, 2, 3, and 4. So the first area of the first triangle is going to be 1/2 times the product of the sides times the sine of the included angle, which is going to be sine of theta 2, right? And then there's going to be plus 1/2 of, let us do number 2. Number 2, it's going to be 1/2 of D times B. So I'm just writing the formulas for the area of each individual triangle. And we know sum of all of them is going to basically add up and give us the area of the quadrilateral. So it is 1/2 of D times B times sine of theta 1. And then guys, plus 1/2 of the number 3, B times C times sine of theta 2. And then plus the last one, the fourth triangle, 1/2 of A times C times sine of theta 1. So that covers all the 4 triangles. Now from here, guys, it is going to be more about mathematical manipulations and using the fact that the sum of these two triangle angles, theta 1 plus theta 2, is 180 degrees because they form a linear pair, right? So from here, guys, what I'm going to do first is I'm going to take out that 1/2 as a common factor, as a greatest common factor. And then what I'm going to do is I'm going to rearrange few things. I'm going to write AD sine theta 2 plus BC sine theta 2. So I'm just combining the quantities which have sine theta 2 together. So I combine these two together, and similarly I will combine the other two which have a sine theta 1. So it's going to be, let me write AC plus BD. Guys, I'm using AC, this one, and this BD. I can write D times B, B times T, does not matter. And then I have, sorry, I want to do it in steps. So it is AC sine of theta 1 plus BD sine of theta 1. Right. Did some rearranging. Now from here, it is 1/2 outside. And guys, again, from here, what I can do is sine theta 2 and sine theta 2 is a common factor, so I can just take it out, and what is left inside is AD plus BC, and then sine theta 2 is my common factor, which I just took out. And then I'm left with AD plus BC in the parentheses. Same thing I can do here. I can just take out sine theta 1 as a common factor. And what am I left with is AC plus BD. And then sine theta 1. Right? Okay, moving on, guys. We may still not be able to see that it is the product of the sum of the product of the diagonals times the sine of a theta 1. But hold on, we're going to do it in steps, and we will make sure that we prove that this is that it is the product of 1/2 of the product of the diagonals times the sine of the included angle. Now, guys, keep in mind theta 1 plus theta 2 was 180 degrees. So if I have to solve for theta 2, it is going to be 180 degrees minus theta 1, right? So what I'm going to do here is this theta 2, I'm going to replace it by 180 minus theta 1, because we know that theta 1 plus theta 2 is 180. Okay, so we are not using something from outside. We are using things that are already valid and that are true for this particular quadrilateral. Okay, so it's going to be 1/2 of AD plus BC, and then I'm going to write sine of 180 minus theta 1. Sine of 180 minus theta 1. Guys, the other reason why I want to convert theta 2 into theta 1 is because the formula that I have to prove has a theta 1. So I want to get the angles in terms of theta 1 rather than leave them as theta 2. Okay, if this said theta 2, then I would have actually transformed theta 1 into theta 2. Okay, so this takes care of the sine theta 2, and we can rewrite that in terms of theta 1. And then, guys, I have to add this other piece, which is AC plus BD times the sine of theta 1. Okay, close the bracket. So I need more space to kind of finally figure this out. So guys, what I'm going to do is I'm going to get rid of this here so that we can write the next few steps. Let us see if we can squeeze in here, otherwise we'll get rid of this as well. But guys, from here, I'll take it up right here. So area is 1/2 of, keep in mind this is AD plus BC. But then, guys, if I simplify sine of 180 minus theta 1, now there's few ways you can simplify it. One of the ways is use the sine of the difference formula, sine of A minus B. So if I use that formula, then what I get for sine of 180 minus theta 1, guys, I'm not going to do all that work here. You can do it on your own. So what I finally get for this is just simply sine theta 1. This simply transforms to sine of theta 1. I just use the sine of the difference formula, okay? There's other ways, but guys, that is one of the quickest ways of doing it. If we don't remember the fact that sine of 180 minus theta 1 is basically sine of theta 1, which you can also see from the graph. So there are different ways of looking at it. So this finally transforms into sine of theta 1, and then I have to add AC plus BD times of sine of theta 1. So I have sine of theta 1, the first one and the second one. So what I can basically do is I can just take out that sine of theta 1 as a greatest common factor or a common factor. So I can pull that out as a common factor, sine of theta 1. And then let us see what is left inside the bracket. Inside the bracket, square bracket, I have AD plus BC plus AC plus BD, right? 4 terms. Guys, we're getting closer and closer to our final form that we want to prove, right? So it is 1/2 of sine of theta 1. Now, guys, in this, what we can do is we can do some grouping. So how about if I group AD and BD together, and then I group BC and AC together. So let us do that. So AD plus BD, and then plus BC plus AC. Guys, we are allowed to actually regroup them, and we are regrouping them just because we want to make them look like this. Okay, so I think now I have to get rid of all this. We need more space. Okay, so from here, what do I have? I have area equals to 1/2 of sine of theta 1. And then this is what I'm going to do here, guys. With these two, I'm going to group these two, and we can see the common factor. The common factor here is D. I pulled out that D, and what I'm left with inside is A plus B. And then here the common factor is C, and what I'm left inside the parentheses is A plus B again. So here we have area equals to 1/2 of sine of theta 1. And then, guys, here A plus B and A plus B again is a common factor. So I got to take it out as a plus b, and then what am I left here is d plus c or c plus d, however you want to write it. And guys, what is this? This is 1/2 of, I'm going to just rearrange this a little bit. Guys, this is 1/2 of a plus b times c plus d and times the sine of the theta one, which is same as 1/2 of a plus b. Guys, a plus b is one of the diagonals and c plus d is the other diagonal. So it is the product of one of the diagonals, d1 times d2, right? That is exactly what these are, and times the sine of the included angle. And that is exactly what we wanted it to look like. We wanted to prove that it is the 1/2 of the product of the two diagonals times the sine of the included angle. So guys, our way of doing this was we broke it into 4 different triangles. We wrote the formulas for each of the areas of each of the triangles. We summed them, and then we have to use the mathematical kind of manipulations, and then we definitely have to use the fact that the theta 1 plus theta 2 is 180 degrees. It's a linear pair, and from getting or solving for theta 2 in terms of theta 1, because we want the final form to look in terms of theta 1, so we used that identity, we applied it, and we simplified things, and finally we were able to prove that it is area of the quadrilateral is 1/2 of the product of the diagonals times the sine of the included angle. Okay, guys, here I'm going to end this application of the area of the triangles and the sine law. Now we're going to talk about the cosine law, and then we're going to do some examples using the cosine law. Again, guys, in some instances we may have to go back and use the sine law, because sine law is basically simpler than the cosine law. So we may have to sometimes again start with using the cosine law, and then we can use the sine law based on like a particular example. Okay, guys, keep practicing these things. If you need any extra help, let me know. I will see you next time.